Hey guys, so here is the second PowerPoint for today. It's on ionic bonding. The big question is why do compounds form? So putting atoms together, most substances are not made up of individual atoms. Instead, they're made up of molecules. A molecule is a group of atoms that are chemically joined together. For example, the air you breathe contains molecules of oxygen, carbon dioxide, and water vapor. So what I'm going to do is pause at the end of each slide so you can get the note down, or if you're following along, I'm going to pause, and that's your point to pause the video. Each oxygen molecule is made up of two oxygen atoms joined together. Okay, so over here is an oxygen molecule. The chemical formula is used to describe the number and type of atoms in each pure substance. So here is our chemical formula, O2. And we can see, when we look at this chemical formula, that we have two atoms of oxygen because of this little 2 here. When we look at carbon dioxide, okay, so here's CO2. I have 1 carbon and 2 oxygens. When I look at water, which is H2O, I have hydrogen, 2 of them, and oxygen, 1. All right, putting atoms together. Okay, so what we want to do is we're going to take a look and count how many atoms of each. So I have 2 fluorines. So there's 2 of them because I'm looking at this little number here. I have 1 potassium. Okay, and I have 1 bromine. Okay, because remember there's a little 1 here, but you don't have to write it. Now looking at here, I have carbon, and I have 3 of them. And then I have hydrogen, that has 8 of them. Now looking here, I have calcium, and I have 1. I have another capital here, so this is carbon, which is 1, and this is oxygen. Okay, and there's 3 of those because of this little 3. Now, the Ag, if you look on your periodic table, is silver. Okay, and I have 1. I have nitrogen, which has 1, and I have oxygen, which has 3. Okay, now I'm going to look here. I have iron, which has 2, and oxygen, which has 3. Okay, I'm going to move on. So atoms are stable when their outer electron shell is full, and it usually happens when there's 8 electrons. Oops. Okay, and we talked about this in the last PowerPoint. So this is your time to pause it to get down the note. Noble gases, so all the elements in group 18, already have 8 electrons in their outer shell, so that makes them completely unreactive. All other atoms need to gain or lose electrons in order to have a full outer shell of electrons. So why do they form? So during chemical reactions, electrons from metals are transferred to nonmetals. While combining, each atom changes into an ion, forming a new substance called an ionic compound. So I put a star here. Ionic compounds are formed when 1 or more valence electrons are transferred from a metal atom to a non-metal atom. And I will put a star there. I would pause here. The resulting is a positive and negative ion, which are attracted to each other, forming an ionic bond. Okay, so since electrons are lost or gained, we're getting that negative and positive attraction. All ionic compounds contain at least one metal and nonmetal. So let's take a look at sodium chloride. So sodium wants to get rid of one electron. So you can see here he has one electron in the outermost orbit. It wants to get rid of it so that the orbit underneath is full. So chlorine, okay, needs one to be happy, so it picks up that electron from sodium and now it becomes full. So since sodium lost a negative charge, it becomes more positive, and since the chlorine picked up that negative charge, it becomes more negative. So we have a positive ion, a cation, and a negative ion, an anion, and they are attracted to each other and they form an ionic bond because positive and negative, okay, they attract each other. Let's take a look at calcium chloride. Okay, calcium wants to get rid of two electrons, okay, to have a full outer shell. Chlorine needs to gain one electron to fill its outer electron shell. So calcium transfers one electron to chlorine, okay, and it still has one to give. So it's able to bond a second chlorine atom, okay, and when it does that, okay, we get one calcium and two chlorines. Okay, I'm going to show you the crossover rule. This rule allows you to figure out how many atoms you will need for each element for bonding to occur, and you don't need to draw a Bohr-Rutherford diagram for this. So first you write the symbols. So we're going to take a look at magnesium here and iodine. So what you do is you write the chemical symbol, the element symbol here, okay, and then you take a look at the ionic charges. Okay, so what you can do is to find out the ionic charge, you have to take a look at your periodic table. So let's take a look at the periodic table. Magnesium, you look in the top here, so for its charge, which is 2 plus, and iodine is 1 negative. Okay, so when we go back into our PowerPoint, you can see we have our charge of 2 plus and 1 negative. So you put their charges above each other. Okay, so Mg, 2 plus, iodine, 1 minus. The third step is to draw an arrow, okay, from the metal's charge, which is right here, because this is the metal and this is the non-metal. Okay, so you draw an arrow from the metal and you bring it down to the bottom right, okay, of the eye. And then you take the non-metal charge and you draw an arrow and put it down to the bottom right of the Mg. So when you do that, okay, you don't have to take the plus or the minus with it, okay? So what you need to do is you need to put the numbers, okay, that you've crossed at the bottom. Now, Mg is going to get the 1 and the iodine is going to get the 2, but we don't need to write the 1 there at all, actually. We just know there's a 1 there, okay? Now, if it is able, say I had a 2 here, okay, I need to reduce that. So that'd be a 1-to-1, so I would just get Mg and I if there was a 2 there. But since there's not, there's just a 1. So this is your new compound name, okay, which is magnesium iodide. Okay, so I'm going to get into how you can name this. All right, so for example, let me just bring up, let's take a look at the naming ionic compound sheet, which is on our homepage. Okay, so remember, so this is very important. Ionic compounds are a metal and a non-metal. So for example, the compound NaCl, okay, and what that is sodium chloride, so okay, but first what you want to do is you want to write down the name of this element and then this element. So you get sodium chlorine. And then what you do, okay, is you write the name, okay, so there are two names, and then you add IDE to the second element. So you change this to IDE. So this compound here is called sodium chloride. This is potassium bromide, so you're changing it to IDE. Magnesium oxide, sodium fluoride, potassium oxide, and aluminum chloride. And you name it this way when you have a metal and a non-metal. So you always have to check what the chemical formula looks like. So this is a metal, it's on the left side of the periodic table, and chlorine's on the right side, so it's a non-metal. So what I'm going to have you do, okay, is I'm going to go through the first example of the worksheet. Okay, and this is on our homepage. So I'm just going to went over this with the class already. So I'm just going to get rid of this for a second. Okay, and what you want to do, okay, now you can write this on a piece of paper, okay, and then send it to me. That's perfectly fine. You want to write the name of the element. So we're going to go potassium plus fluorine here. So you're going to write the K and the F. Okay, so you can write this on a piece of paper, and then you have to check the charges. Okay, so we got to go here and take a look. So F is a -1. The K is a +1. So I have a 1 plus and a 1 negative here. And then you want to show me your cross. So 1 plus, 1 negative. So you take the cross and you're going to put it down by the F. You're going to take this one and put it down by the K. So what you get is 1, K1, F1. But we don't need to write the 1, so all you need to write is K and F. And what that comes out to, okay, and what you want to write is the name of the elements. So we have potassium and fluorine, okay, and then you want to change the ending to IDE, potassium fluoride. Okay, if you want to write it out, you can show it to me in this form here. You have your two element names with their charges, and you show me the cross. You show me the final compound, and then you name it. Okay, and I'm fine with that. All right, and I would like you to try the next 3 on this sheet, and then you're going to take a picture and submit it to me by the assignment icon. Okay? All right, have a good day, guys. We'll see you later.